So as we go into the second unit on this, we're going to be measuring angles and arcs. Okay. Now, I want to make a definition here. You're going to, in angles, you're going to see two, or in circles, you're going to see two different types of angles. Today, we're talking about a central angle. All right. And that central angle means that the vertex of the angle starts at the center of the circle. So this is a central angle. Okay. The other type of angle that you're going to see in a couple of units is called an inscribed angle, where the vertex of the angle is on the circle itself. Okay, so this is central, this is inscribed. Now here's what's important about the central angle. You understand that if I measure up all of the angles in a circle together, what does it equal? No? What do all of the angles in a circle equal? No? 360. Okay? A circle is 360 degrees. Okay? So if I add up all the angles in a circle, they equal 360 degrees. And that's what this says right here. If I was to add up angle 1, angle 2, and angle 3, all of these will always equal, no matter how many central angles there are, 360 degrees. Okay? So, if we look at this example, how would we solve this? How would I find x? I get that, but I have a measure for this central angle. I have a measure for this central angle. I have a measure for this central angle. And I have a measure for this central angle. I don't know anything about this one right here. So I could go ahead and take this one, and this one, and set it equal to 180 degrees. Tell me that again. Equals it to what? Because, again, this is what I was saying before. I know this angle, I know this angle, I know this angle, but I don't know anything about this angle right here. They didn't give me anything for that. So I can't add all of these together and set it equal to 360 because I don't know what this is. Okay? But I can take these three and add it to 100 and add it together and set it equal to 180. So I have 8x minus 4 plus 13x minus 3 plus 5x plus 5 and set that equal to 180 degrees. And then I would solve for x from there. Okay? All right, so let's go back to this idea of a central angle. Okay? If I have I can't do that very well. Let's draw more of an official, like, clear picture. This. All right, so this is my central angle. Okay? Whatever the measure of this angle is, let's let this angle be 100 degrees. Okay? Then the measure, so this angle right here has an intercepted arc. Okay? This is the part of the circle that the angle intercepts. In a central angle, if the angle is 100 degrees, the measure of the arc is also 100 degrees. Okay? So what does that make this arc right here? It makes this arc 260. Okay? Now, if an arc measures less than 180 degrees, if this arc right here is less than 180, we call it a minor arc. If the arc is more than 180 degrees, of course, we call it a major arc. And then if it is exactly 180 degrees, we call it a semicircle. Okay? Now, this is what I want you to keep in mind. When you're looking at the measures of these arcs right here, this says X, Z, Y. When you're looking at the arc itself, go in the direction the letters tell you. So X, Z, Y. Okay? Sometimes you'll have a lot of letters and it might get confusing as to which direction you go. Is this a major, minor, or semi? It's a semicircle. Okay? Because this, if this is the diameter, this is 180 degrees, that makes it a semicircle. Okay? If we look at the intercepted arc for WZX, so WZX, major, minor, or semi? Major. And then XW, major, minor, or semi? It's a minor arc. Okay? All right, so I'm going to skip this. We're not going to do this today. All right, and so then if you take two arcs together, let's kind of draw this out for a second. This, and I'm going to let this arc or this angle be, let's say, 48 degrees. I'm going to let this be 87 degrees. Okay? What is the measure of that arc right there? Hmm? 135. Okay? And that's all this theorem said before, was that, look, if I have arcs or angles side by side, I can add the arcs together. So, if I'm looking for the measure of the arc, LHI, what's the measure of this arc right here, LHI? Dawson, you agree with that? Why? My man, good job. All right, so if this is 90, then this angle is 90. And so if this angle has this for an intercepted arc, it's 90 degrees. All right? What's the measure of I, J, K? Now this is where it gets into problem solving. This is where it gets into kind of a puzzle here. What'd you say? How did you come up with 148? Okay, so this is what Connor's saying. Look, if this is the diameter, then this whole thing right here is 180 degrees. So if I subtract this part out, 180 minus 32 is going to give me 148. Okay? Now, there's another way to look at this too. And again, this is kind of where the problem solving comes in. What's the measure of this angle right here? No, this one's 48. Is it 58? It is 58. I'm sorry, you're right. 58. So this is 58. And because these two are vertical angles, this is 58 as well. So if this is 90, then I could take 90 and 58 and still get 148. So it's just kind of to show you that there's a couple of ways in a lot of cases to be able to solve these problems. All right. God, that's awful. All right, I want to show you something here for a second. Do you understand that we said before that if I have this angle right here, right? This angle is a part out of the whole circle. Do we agree with that? Okay. Now, the max it could ever be is 360. Do you agree? Okay. So that means that this angle, this arc right here, is whatever that is in degrees. Okay. Now, if we start to talk about distance, the distance around the circle itself, the distance around the circle itself is circumference. All right, that's the distance around the circle itself. Now, if I want to measure the length from here to here of this angle, the length of this part of the circle, the length of this part of the circle is a part of the circumference. Okay? So I can set up a proportion by doing that. You with me so far? Now, if I want to solve just for this length, I would multiply both sides by 2 pi r. And so this would cancel out, and the length is by itself. So this is where we come up with the rule for arc length. Arc length. And that is the length of the arc is equal to the central angle over 360 times 2 pi r. That's the rule that you have to know. The arc length is the central angle over 360 times 2 pi r. All right, so if I come back over here and I want to find the length of the arc dA, I want to find this distance. Then I'm going to have to know what that central angle is, which in this case is 40, over 360 times 2 pi and the radius 4.5. You with me? Now, just like circumference, in circumference, you leave your answer in terms of pi. You do the same thing with this arc length. Actually, no, round to the nearest hundredth. All right? So, plug that into a calculator and see what you get. All right? Let's do this one right here. This will be your last one. 28. So the big thing is just being able to set it up. We have the central angle over 360 times 2 pi 6. Oh, I'm sorry. You're right. dA. So you're right. Thank you. So 152. All right. What do you get? Round to the nearest 100. 15.9. No, just round to the nearest tenth or hundredth. Most of the times it'll say tenth.